with the y equals cosecant of x function. So just to review with you, these are the parent function general equations for the sine of x and cosine of x. You have your amplitude, how you find your period, reflections, up or downs, and then your left and right endpoints. So this should look familiar to you. What we're going to graph now is y equals 2 cosecant of x plus 3. So I'm going to just rewrite this as y equals 2, and I'm going to change it from a cosecant to a sine. If you remember, the reciprocal function for a cosecant is the sine function. So we're going to pretend right now we're going to be just graphing the sine function, not the cosecant. So let's take apart and identify the 2. And what the 2 tells us is the amplitude. So the absolute value of 2 is 2. The period will be next. So you look for the b. The b is 1. So then your period is 2 pi over 1, which is 2 pi. Then are there any translations? Yes. We're taking this 3 and it's moving it up 3 units. So instead of being on the horizontal axis, it's going to be up 3 units. Are there any reflections? No. There's not a negative 2. Now let's talk about left and right endpoints. We have to worry about left and right endpoints. Is there any parentheses here? No. So we don't have to worry about left and right endpoints. So our starting point will be at 0, and our ending point will be at 2 pi. All right, so to review, to graph a cosecant function, you always graph its sine function first. So with us having to shift up 3 units, normally my x-axis would be here. I'm going to shift up 3, so 1, 2, 3. I'm just going to label this as y equals 3. Then from that horizontal axis, I'm going to go 2 up and 2 down because that's my amplitude. So I'm going to go up to 5. Here's 4. Here's 3, 2, and 1. So my graph is going to exist from here to there. Now my period was 2 pi. So I'm going to start at 0. There was no transformations left or right, so to 2 pi. Split up into 4 equal parts. Halfway is pi. Halfway again is pi over 2. Halfway again is 3 pi over 2. I'm going to do one more revolution. So I'm going to add another 2 pi on. So it would be about here. This would be 4 pi. Halfway would be 3 pi. Halfway would be 5 pi over 2, and 7 pi over 2. All right, we're set to graph our function. Remember, our function is the sine function. So sine functions start in the middle. There was no reflection, so it's going to go up to the top. It'll start in the middle of that new axis, work its way up to the top, to the middle, to the bottom of your amplitude, and then back to the middle. There would be one revolution. Now we're going to continue. So we'll go up to the top, to the middle, to the bottom, to the middle. Another revolution. All right, now we're creating the asymptotes. Now the asymptotes before were on the x-axis at 0. Just imagine our x-axis is now shifted up 3 units on the purple. So here would be a 0, here would be the next asymptote, the next one, the next one, and the next one. So we create those asymptotes vertically. And now our cosecant function's graphed out. Top of the hill, parabola. It's not truly a parabola, but that's just kind of how it looks. Bottom of the hill, parabola. Top of the hill, parabola. Bottom of the hill, parabola. There is now your new cosecant function with all the transformations.